Welcome to the International ASABE Quarter Scale Tractor Pull Competition.
Greg Tramey, I'm the chair of 2011 ASABE International Quarter Scale Tractor Student Design Competition. The competition is broken into several main events. It starts with a written design report, which all schools submit prior to actually coming to the competition here. Within that written design report, there's also a cost analysis section where they will determine the production costs of their tractor based off of the market that we give them. They'll then do, when they arrive here at the competition, they will go through a technical inspection section to ensure compliance to all the rules of the competition. They'll do a static design judging section where they will be judged by a panel of industry experts on several different key areas of the tractors. There's a performance event that consists of two separate events. One is a maneuverability event in which a course is set up, basically an obstacle course that they have to drive the tractors through to determine which tractor is more easily maneuvered by the operator and just really the overall drivability of that vehicle. And then the main event really is a tractor pull event in which we use a progressive weight sled that increases the weight as the tractors pull farther down the track. So that's the majority of the points for the competition, but they're spread out really across the entire events that I've talked about. So.
Hi, I'm Darren Drollinger, the Executive Director with ASABE. I'm here at the ASABE Quarter Scale Tractor Competition. For me, I'm particularly excited to be here. Over the years, I've had the opportunity to see quarter scale action and talk with those schools and students that have done the hard work to make this come about, but I've not had a chance to actually participate firsthand in the competition, and it's exciting. It really is incredible to see the students apply the engineering principles and practices in a real-life setting in order to bring together and make these tractors compete. It's an excellent collection of engineering skills, practical know-how, and everyday interest. And through these experiences, these students will go on, a great many of them will form networks and connections that will provide future job opportunities and friends for life.
My name is Ron McAllister. I'm the president of ASABE. These students have used many of the skills that they're going to need when they get out into the working world. They've learned how to work as teams. They've learned how to solve problems. They've learned how to make the machine work better, and many of these skills are going to be needed when they get out into the workplace. They've learned how to use their engineering training. So it's been a great experience for them and prepared them, and they will be better employees for someone in the future.
Jim Capriva, and I'm the first vice chair of the 2011 International Quarter Scale Tractor Student Design Competition. We basically look at the entire tractor and inspect the whole thing. It takes about 2 days to do all the tractors here. And what we're looking for is to make sure that the team's tractors comply with our performance event rules and regulations. And this includes everything from the overall size and weight to the tractor, to all the safety, shields and guards, brakes, engine, all the setting the engine speeds, as well as fuel system, electrical systems on the engines. All of that is checked. We have basically 6 different stations that all the tractors have to go through. 2 of them are strictly a safety of guards and covering up the drivetrain and all of that. One of them is a brake test, where we actually have a stand that inclines the tractor. The tractor has to be able to hold the brakes or hold the wheels fully ballasted. And we also check the integrity of the wheelie bars, the hitch, and the structure of the tractor in general to make sure they're safe. There's 2 stations surrounding the engine. One of them is basically the engine itself, where we check the speeds of the engine, as I stated before. And then we also look at the exhaust temperatures, make sure that the exhaust shields meets ISO regulations. And then the other one is checking the disconnect of the engine. The teams have to be able to disconnect their engine in less than 2 minutes per engine on each tractor. They also, hydraulics is the other thing at that station. We check the hydraulic system pressure and all the safety of the lines and the routing of the lines and all that as well for the hydraulics. Another portion of our event is the maneuverability competition, and we added this several years ago to encourage teams to design tractors that were more practical. Not only could they pull, but could also maneuver around. And so we set up a course that the tractor has to go through, and there is there's three objects in there the tractor has to touch, and then the rest of it is surrounded. The entire course is surrounded by the posts with the golf balls on top of them. And any of those the tractor hits, moves, or knocks down are points counted against them. So that's the reason, like I say, the reason for that was to encourage teams to design tractors that were more practical, could be used in other applications. So it's also a big part of our event.
Hi, I'm Mike Salino. I'm the 2011 ASABE International Quarter Scale Tractor Student Design Competition co-chair. Another aspect of the competition is the sound judging part of it, where we actually have the tractors do a pass-by driving sound test that we measure sound levels. It's a static design judging where it's more of an interactive part of the competition. Design judges, which are members of industry and different engineering applications and marketing segments that come out, they actually get to meet with the teams and basically get to sit, climb around in their tractors, provide feedback, ask questions and submit comments to them based upon their design in different areas. The areas that we focus on include manufacturability, serviceability, safety, ergonomics, and testing and development.
This is how we really see how these machines perform. So we've gone through all the design, through all the teching. This is really how we see what these machines can really do and put them to the test. What we have is a progressive weight sled. So as the tractors get further down the track, it gets harder to pull the sled. And the further you can pull the track, the better your tractor is going to be at being able to really get traction and transfer power from the engines, regardless of what you're running, 2, 1, the small engine, the big engines, really get them to the ground and the most efficient way. It's really the test portion of this competition. We pull 2 different weight classes, a light weight class at 1,000 pounds, a heavy weight class at 1,500 pounds. In each weight class we are pulling 2 different chain positions, one at the bottom of the sled where there's a little more downforce to the machine and it's a little easier to get weight transfer onto that to the rear axle. Then we raise it 5.5 inches from that for the second pull in each one of the weight classes. What that does is it makes it a little difficult to get that weight transfer to the rear wheels and really be able to put the traction on the ground. So you'll see some of these front wheel assist machines that have the front drive tires as well. That's what they're trying to achieve is that as they have a harder time getting weight to that rear axle, they're trying to put more weight out on that front axle and make it an actual driving axle as well.